Okay, let's talk about evaporation. So, in order to understand this, let's just take a beaker of glass, fill it with water, and put it on a hot plate and see what happens. So, as we heat it up, it reaches a boil, some bubbles form, those rise to the surface, and on the surface of the water, evaporation occurs. And so, some of that water mixes up into the air and moves out, and that sort of spills around, and you've got evaporation. So let's look at this a little bit closer, just a little bit more on a molecular level. So if we have a sort of a close-up here again, and here now we're looking at the molecules involved. Well, we've got sort of surface molecules, and then we've got inside molecules, and these are all moving around and bumping around, and they have some kinetic energy, which we interpret as heat. And so this hot plate is adding energy into the system, and so that causes maybe this guy to have a lot of energy, and this guy gets some more energy in addition to what he already had, and so moves off that way, and all of this new energy being increased and increased, and eventually some of the ones at the surface, they're going to get some energy from a molecule, and they're going to get enough energy to actually be removed from the chemical bonds holding them together into the liquid, and so that breaks, and now what we have is essentially a gas floating up in the air, and that has energy, and that continues on its path, and another particle and another, and so from this we can see that a water molecule can only really get out there if there's space for it to get out into in the first place. So if, say, we put a lid on the top here, and this was all perfectly coated, so there was no airspace here at all, there's nowhere for these energized particles to go, and so they wouldn't evaporate. There's no way they could. Since we can't really compress water, it just always stays at that same place, and so no matter how much we heat it up, it's always going to stay a liquid. So, knowing this, let's think about some ways in which we can speed up, the process of evaporation. So what's a very simple thing we could do to make this beaker of water evaporate just a bit faster? Well, what we could do is remove these walls, and we know that the gas particles are going to take up space, and that's actually going to prevent more evaporation from occurring. So we need to get rid of these guys, and we can use a fan or maybe put it outside and let the wind blow it away. But this is going to blow all of those evaporated particles off into the distance like that, and that's going to give space for more to appear and more to come out of the surface of the water. And so by adding the fan, by adding wind and removing the top layer of water mixed into air particles, that sort of gas, moving that away, we get a much faster evaporation process. Now, another thing to note, and this again might seem counterintuitive at first until you think about it a little bit closer. The hottest part of the system, this system here, including the water particles, the surface particles that are represented by this double line here, and the gas particles, the hottest part is this area right above, of the gas, right above the surface area. And the coldest part is the surface area. And here's why. As one of these particles gets enough energy to move out, it moves out of the surface area. Now it becomes part of the gas area. So now it's in this just exited the surface area moment. Here, it hasn't had enough time to lose energy, right? We know that over time it's going to lose energy, it's going to condense and then fall back down. And over time, it just slows down. It loses that heat energy, and it becomes colder and colder over time. And so here, it hasn't had enough time to really slow down, and we know it's got enough energy to evaporate because what was at the top, we know that the hot stuff expands, and so in here we see a similar sort of cycle of temperature, but some of it is escaping outwards when it has enough energy. And so that's why this top area is the hottest, and this is the coldest because that energy comes from there, and so that's constantly losing energy and actually cooling down as a process, as a result. And because it cools down, that perpetuates this cycle here. So that's how evaporation works.